All right, today we're going to discuss the gas giants, the Jovian planets, and here we're going to be focusing on how much hydrogen they have. They have tremendous amounts of hydrogen, and kind of a secondary part will be helium. And they will actually have rocky and metallic inner cores, but they have so much gas they're going to be extremely low density planets. And of course, you're going to have these cold temperatures as the further you get from the sun, and we will actually be getting into these ices of ammonia, methane, carbon dioxide, and clearly ice as we know it. Now, Jupiter here, we've had a chance to lecture these on another one, but just make sure we realize that we have 4 primary moons that we're looking at. They are called the Galilean moons, and they are Io, Europa, Ganymede, and Callisto. And Jupiter is about 5.2 AUs away from the sun, and its orbital period is 12 Earth years, but its rotational period is 10 hours. So it takes a long time to orbit, but it takes a very short amount of time relative to Earth to rotate, right? Less than half. And here we go. It's covered the gases, the surface of it. If I look at the surface of Jupiter, it's dominated by these different gases. They're red, yellow, brown, white cloud bands. And that's what we're seeing here. And these are moving in all kinds of directions. Some are traveling east, some are heading west, and they kind of interact, and they create these large eddies of storms. And once again, 71% hydrogen, 24% helium, and only 5% other elements. The thin rings, Jupiter does have rings. It has 3 thin rings, and they're made up of mostly dust particles. And they're hard to see. Jupiter doesn't get quite the notoriety of having rings as Saturn does, because Saturn's are a lot larger and more pronounced. So Jupiter here, once again, it has the great red spot. It's rotating counterclockwise, and it's simply a function of the direction of the storm bands that are moving in opposite directions. The great red spot here, we've got, it's about 3 Earths can fit inside of it. The great red spot itself has been going on. It's a major storm for many, many hundreds of years, and it's probably got a couple hundred left. There's also another spot that's growing in the southern hemisphere of Jupiter too, and we won't get into that today. Here we have convective cells. The light colored bands are generally air that is convectively rising, and the dark bands are sinking. So we've got these differences that are moving the air and oscillating them. And notice the dark bands are moving in different directions than the light bands. Here we have the metallic, the liquid hydrogen core that's acting like a metal. And the magnetic field results from the fast rotation of the internal metallic core, right? So it does have a dynamo effect. It just doesn't have liquid metal. It has liquid hydrogen, which behaves like that of a metal. And the interior is believed to contain as much rock and metal as terrestrial planets. So the largest magnetic field in the solar system in terms of all the planets. And then these are the 4 planets that I gave another lecture on. So we don't have to go over those. But Io, Europa, Ganymede, and Callisto. So this is the lecture that you can watch. It's embedded into the lecture slides. But let's jump into Saturn. Saturn is the 6th planet from the sun and the 2nd largest overall. Jupiter is clearly the largest. Saturn is a gas giant. It is 1/8 the average density of the Earth, but Saturn's volume is 95 times greater. Saturn, if we had a container of water large enough, would actually float in water. It's 0.7 grams per cubic centimeter. So very low density. Very low density because it has so much gaseous material. So it just has a very large volume of very low density materials. It has electrical current within the metallic hydrogen layer. This is what creates Saturn's magnetic field, which is slightly weaker than Jupiter, but still extremely large and fairly powerful. Saturn has an outer atmosphere that can have very strong winds. Saturn's 62 moons orbit the planet. This does not include the little moonlets within the rings. So these are the rings, and we'll talk a little more about them in just a moment. So Saturn is roughly 70% hydrogen. Its yellow appearance due to ammonia that's present in the atmosphere. It's got large white spots due to thought to be large storms, like the great red spot on Jupiter. And the wind speeds reach thousands of miles per hour. So Saturn has the fastest winds in the solar system. So what are the rings? Well, the rings are made up of just tremendously large number of tiny dust, ice grains, rock, just debris that's caught, and it ranges from, like I said, the tiny microscale to the size of mountains. The rings are believed to be comets and asteroids or shattered moons that were broken up if they get too close within the Roche radius. Saturn's been known to just gravitationally kind of smash them up, and they just move around it in these different bands. And from Earth, the rings look like a solid sheet of material, but they're actually made up of billions of rocks, ice, and dust. And these particles range from minuscule to microscopic to the size of houses and cars. The brighter areas are just areas that reflect more light from the sun than the darker areas. So the darker regions just have a lower density of dust and debris, where the lighter material has just a higher density. A couple of moons. Titan is the second largest moon in the solar system. Only Ganymede, right, that's Jupiter's moon, is larger. Titan is even larger than Mercury, and it's roughly the same size, Titan here, roughly the same size of Earth's moon. Saturn's moon Rhea may have had its own rings and a thin atmosphere. And Enceladus, it has an icy shell and solid heated biflexure like Jupiter's Europa. And this one actually may harbor liquid ocean between its heated interior and frozen exterior. So this will be an area of study when we look for liquid water. And Enceladus also has geysers spewing water and ice that contribute to Saturn's ring structure. A very unique feature that it has a moon that's providing some of the debris that gets caught up in its ring field. So kind of cool. And then here's a picture that was taken from Voyager 2, I believe. And these are just these are pictures of high definition photos that were taken from a passing by, let's just say, spacecraft that we were filming. Moving on to Uranus. Uranus is the sideways planet. Notice it is a sideways planet because it rotates along an axis that is, let's just say, it's in the same direction. Its axis is in the same direction or close to the same direction as its orbital direction. So it's kind of crazy. While most planets have rocky molten cores, the center of Uranus is thought to contain icy material. The liquid core makes up about 80% of its mass. The internal heat is lower than astronomers would predict, but it's pretty cool when compared to the cores of other planets. While other gas giants are powered by their core, Uranus radiates almost no heat into space. This could be due to the large impact that led to its sideways spin, right? Giant collisions that took place in the history of our solar system. And the impact is believed to have carved out a portion of its core, leaving it with a lower temperature. It's definitely considered the sideways planet, and it also has what we call a retrograde rotation. So Uranus is the seventh planet from the sun, a distance of 19.2 AUs. One day on Uranus takes about 17 hours, and Uranus orbits in about 84 Earth years. So it's an ice giant. Roughly 80% ice and water, methane and ammonia surround a small rocky core. The atmosphere is mostly hydrogen, right? There's that key again, and helium, with small amounts of methane. Uranus has 27 moons, and they've been named after works from Shakespeare and Alexander Pope. Uranus has faint rings. It does have rings. The inner rings are narrow and dark, while the outer rings are brightly colored, so there's a greater density farther out. And it has retrograde rotation. This actually rotates east to west like that of Venus. Remember, Venus and Uranus have retrograde rotation. Rotation is around the internal axis, so remember that. And Uranus rotates on its side, which means it spins horizontally. So it's kind of cool. It's kind of vertical. It's kind of crazy to think that that's the direction. And here's some cool pictures here. This is infrared picture of Uranus and its rings. And last but not least, Neptune. It's the eighth planet. It's about 30 AUs from the sun. One day in Neptune takes about 16 hours, while its year takes about 165 Earth years. Neptune is a sister ice giant to Uranus. Neptune is made up of very thick, hot combination of water, ammonia, and methane over a possibly Earth-sized solid core. Neptune's atmosphere, once again, here comes hydrogen and helium and methane. It is blue in color. Take a look at these pictures here. This is from Voyager. Voyager 2 is the only spacecraft to have visited Neptune. At times during its course around the sun, the dwarf planet Pluto is actually closer to the sun. It falls between Neptune's orbit, and this is due to Neptune's unusual elliptical egg-shaped orbit. We call that the eccentricity, highly eccentric orbit. And Neptune has one large moon called Triton. Do not be confused with Saturn's moon Titan, but this is Triton. And Triton has active geysers that are visible on its surface. So that's kind of a cool point too. So we've gone through all of the different planets in the solar system and different unique features. I do want to make sure you pay attention to the astronomical units. You'll have information provided. You'll need to know what to do with them. And these are the distances in which they are from the sun. Periods of revolution, right? That's how long it takes to orbit one time. The inclination of orbit, the orbital velocity. Notice much faster closer closer to the sun, and the further you get, even Kepler's laws coincide this value. Orbital velocity decreases at distance. Period of rotation, here are values of rotation. Here's the diameter and in both miles and kilometers. Relative Earth masses. Here we have average density. I want to make sure you pay attention to Saturn. Saturn would float in water. We're not worried about polar flattening. Mean temperature, right? The further you get, with the exception of Venus. Venus is extremely hot. Extremely colder as you get further, right? We're getting farther from the sun. We have less intensity. And then the number of known satellites. And there you have it on the outer gas Jovian planets.